Okay, so you can draw this picture about how the water can interact with the carbon dioxide. What kind of interaction does this need to be, what would we call this interaction? Dipole induced. Dipole induced. Okay, so we got a water molecule. This side over here is partially positive. This side over here is partially negative. Weird. And then I've got a carbon dioxide molecule. And it's got a undispersed electron cloud around it because it's a non-polar covalent molecule. So it's evenly distributed. And then these electrons here push those away. And so I get a partial negative on this side and a partial positive on this side. And then I get an intermolecular force of a temporary nature attracted to those water molecules and carbon dioxide molecules. How do you know this isn't a very strong intermolecular force? Just from like life experience. You crack a can of Coke or a beer and you come back in an hour and it's kind of flat. You come back in 3 hours, there is no carbonation left whatsoever. Just the idea that you crack it open and it's like, how about opening a warm 2-liter bottle of soda? Have we made that mistake? It just immediately overflows. Like if you don't like crack it and then close it and crack it and close it, like if you just twist the top off, you got soda everywhere. And that's this intermolecular force that is not very strong, but it's a dipole induced dipole. All right, look up the boiling points of these 4 and then talk about them. So I don't have them in front of me. Do you guys have the boiling points?
Yeah, methane is, I got, everybody's got 2 or 3 dimensions, negative 164.
Yeah.
Ethylene, negative 89. Propane, negative 42, and butane, negative 1.
I'm assuming they're all C.
Yes, sorry.
Okay, so the methane obviously boils at a very low temperature, meaning under almost all conditions, it's a gas. And so what is the reasoning behind the difference when really what we're talking about is CH4, C2H, 6, C3H8, and C4H10. They're just all covalent molecules that are nonpolar. So why do I have a much higher butane temperature?
Just more of them.
Yeah, there's 1 carbon, there's 2 carbons, there's 3 carbons, and there's 4 carbons with the butane. So 2 carbons next to each other, like some sort of interaction between 2 methane molecules, CH4s, there's not a lot of interaction ability. There's not a lot of surface area for them to touch. But on the bottom down here, if I've got 2 butanes next to each other, they can interact with each other all over the molecule. And so it's just 1 piece of Velcro, 4 pieces of Velcro, 1 button versus 4 buttons, that kind of situation. So what do these intermolecular forces all have in common? The dispersion, dipole induced dipole, dipole dipole. Yeah, you can call them van der Waals forces. Yeah. These are all covalent molecules interacting with other covalent molecules. And not very strong. Okay. What do we have for the melting points for neon and xenon? Those have got to be ridiculously low.
Negative 248 C and negative 111.8 C for, you know.
And reasoning? Yeah, so there's only 10 electrons here and xenon's got 54. Is that right? Can't read that from here. Yeah, 54. 54 electrons. So as two neon atoms approach each other, there are only 10 electrons to skew. So if I'm a neon and I got a cloud around me and I approach another neon and it's got a cloud around it, if these guys are going to move those, they're only moving, 10 total electrons, where with xenon, the cloud is huge by comparison. So if I'm going to skew this cloud, I can skew it a lot more because there are simply more electrons. This was the example of the which dodgeball would be the softest, and it's that one that's 8.5 feet tall. You can really squish into that one. Your DNA, what's that thing? What's your DNA composed of?
Oxygen and hydrogen, so a whole bunch of hydrogen bonds.
They're nucleotides. They're those 4 nucleotides, and they're connected by hydrogen bonds. So you've got independent strands that are attracted to each other because of the hydrogen bonds on the adjoining strand. Okay, how about this Girardi bug? Yeah, these are those little water skeeter bugs. So how's it that they're able to float on water?
Surface tension and short.
Yeah. Do you know how to make a Giardi bug like cry? We talked a little bit about it on Wednesday. A little bit about surface tension.
Throw it under a waterfall,
Yeah.
put some soap on the.
Yeah, like a single drop of Dawn. They'll be like, shh, shh, shh. Then they'll hit that soapy water and they'll just go in. And they'll pop up over there and be like, what the hell? Like, why am I wet all of a sudden? Yep, if you used the bubbling thing, they would avoid that. When you see them, they're usually on creeks and ponds that are still. Yeah. Okay.